data and you paste in the less accurate data, because the paste E, or the less accurate data, is going to get changed. Okay? You don't change the more accurate data. In other words, the edge conditions to match are going to change on the less accurate data.
So when you're kind of like, I'm not sure if this is the right term, but we have your accurate data, and then your less accurate data will like break line or
let's say it's your aerial, and then you have your survey. Okay, you have your survey, and you told survey that you want cross sections at 25 feet. Okay, and you have that surface built is basically good to the back of walk. Okay, or the back of parkway, and so that's your detailed surface. You cut out of the aerial plus or minus 3 to 5 feet beyond that back of walk. Okay, so you just take the back of walk and then cut it, and then paste in that aerial surface. Okay?
Go ahead, go to your file.
So once you've created, I actually made it on your C drive. So once you've created the surface, it should look like this. Okay? So I'm using a surface that has a boundary on it, and that boundary has a label. So let's see, existing aerial. Nice.
Did it really freeze up again?
No, that's doing, it applied the name to the.
You gotta right click on the surface and go to edit surface style.
Or edit, surface properties. So, and again, your surface style is going to be existing contours.
When you create your surface, the default surface style is EX1 and 5.
So when we look at this, we have a pretty nice surface to go from. And one of the nice things you should do is actually look at the surface and see if it agrees with the data you have. Make sure that, it's agreeing with the data. You have what looks like a driveway here. So that agrees with it pretty well. Looks like there's one errant triangle there. But you have another driveway here and another driveway here. So you can see from the data what is actually there, but always tilt that thing up and look at it and see if you have, and you can change the style to the triangles and see if you have a triangle that's going down to 0 or a triangle that's going up to 100 plus. Okay, so take a look at that data, and then, like I said, be able to cut from the back of walk out this data here, but I don't want to change my existing surface. Okay, crop the surface and call it a different name. Okay, I can't stress this enough. Keep the surface as is. You want to use that later on, maybe to compare your surfaces and make sure what it changed. Okay, you can compare the new composite surface to this and see what kind of delta you have against that surface. You'll see that maybe it varies. Maybe it's 6 inches different here, but only 3 inches different here, and less than 2 inches different here. Okay, it'll tell you something about the data, but always keep the original. Copy it over, make the change in the copy. Okay, change the name. Also, never move this file. Please don't archive it, because once you've created shortcuts and you move that file, and all those shortcuts, goodbye. They just disappear, they break. Okay, so anything that had this referenced into it no longer has it referenced into it. Now, can you fix those? Yes, but a lot of times it won't fix, okay? So just keep that in mind. The other thing when dealing with surfaces is save often, okay? Just like I just had, freezes up for no reason. And it does that mostly with surfaces. But as you can see, that surface is fairly good without having to actually do any editing to it, okay? When I brought in the break lines, brought in the points, the surfaces, except for maybe this little bobble right here, okay, did pretty well on its own without having to mess with it and do any edits whatsoever. So again, the routines have gotten better over time. They're not perfect, okay, but they do a pretty good job, okay? So just see what the surface looks like before you start editing it massively, okay? The other thing is check these contours against what the aerialist came up with and see if they are close, okay? They should be, because this is the data he used to get the contours, okay? Any questions, thoughts, ideas?
When you're creating your surface, what's the correct order of operations? You're going down through the list, or should you end with your boundary, or is that the first thing you should be picking?
You end with the boundary, because if you add data after you add the boundary, it no longer respects the boundary, especially if that data is outside that boundary.
You can't start with the boundary anymore because it wants data before it will let you place a boundary.
Correct.
You
The
cannot
other-
add a boundary to an empty surface definition.
Right. Now, it will take any kind of data. You know, as he'd shown, we had brought in points and I called them aerial. So in here, that's where the description shows up, okay? If you don't have any description there, it just says point. I don't know which points we got, okay? The other reason to use point groups is if you use a point group that's imported and for some reason there's some edit to that, those edits are now affecting your surface. So keep a separate point group just for your surface, okay? In addition to that, we have kind of a change in the surface names. Keep that in mind. We'll be sending out the information in a little bit. We'll also have this recording available for you. It's also on a YouTube channel. We'll send that out as well. So you can have that recording as well. But we want to stress, know where the data is coming from, okay? Where is that data accuracy shown typically? And surveyors be quiet.
So what Mark commented was, this surface actually looks pretty good, right? Like we can see that the street has a pretty good crossfall. We're getting definition of our curb and gutter. We're seeing pretty good definition, right? Would we use this surface to do street rehabilitation plans?
No.
No, right? Why?
This is level 1 accuracy.
Level 1 accuracy in terms of where this data came from, right? Came from a aerial. We need a design off of highest level, which is survey data, either GPS or total station.
Yeah,
right?
that's
So-
what happened in the, in the payout of the part of that $100,000 is they designed from this aerial data.
And
Okay.
even though the surface looks good, it's bad information. All right, so we want to be sure that's kind of the overriding subject here is more than just the process of creating surface tens, but knowing how good they are and what they should be used for.
And that data comes from the surveyor's survey notes, okay? In there is going to be the cover sheet in which they, which datum, which benchmark, which bases of bearings, okay? All of that is in that information. In addition to that, if they collected it with a theodolite, there's going to be a level run, and the level run is in there, and it's just a copy of their book, basically, giving you the notes that they write, okay, and giving you the accuracy that they came up with out in the field. In addition to that, when they do a dip or a invert elevation, they will draw a sketch of the manhole or the storm drain, okay, and show you what elevation is coming in, in which direction, and the size of the pipe. Okay, they'll have an 8-inch clay pipe and a 10-inch PVC and a 12-inch PVC going out. Okay, they'll have that data in there with all the elevations. Okay, a lot of times if it's flat, they'll just give you a center elevation because basically all the inverts are basically the same. If it's, they're talking about a really flat sewer, unless you told them to get more accurate information. If you wanted something down to the 100th. But again, it's not down to the 100th if the level circuit is at 200ths. So keep that in mind. All right? I've seen people use aerial survey and take the accuracy of the earthwork down to 100th of a cubic yard. You're lucky if it's 50 cubic yards or 100 cubic yards. Okay? So be aware of the accuracy.
Any questions or comments? Steven?
Question. So surface files or the surface Civil 3D file is heavy.
Yes.
My project manager asked for contour labels so that you can see what contours or what elevation. Where's the best place to put that surface so I can link it?
So there's a couple different ways of doing that. Probably the lightest way is to create a standalone file, data shortcut your surface in, create your labels, right? Then you can actually explode those and export those to a separate file and just have it be a text annotation. That way you don't have to reference in the surface at all. You can just have, because that's ultimately what you're after, is these labels that are not going to change because your surface isn't going to change. So you can just extract those labels.
And so anything that you have in the surface that's displayed, okay, you can extract. The way you do that is go to Modify, Surface, or click on the surface, and then over here is Extract from the surface. Anything that's on at the moment can be extracted. In other words, if it's in your style and it's on and on the screen, you can extract it. Okay?
That's a good question.
When we get, say, information from aerial and then survey goes out and picks up, say, vaults and manholes and other such things, when it comes time to build the surface, are we including that in the aerial surface, or are we calling that the composite surface? What's the proper way of communicating that we got aerial and survey?
So you should have two separate surfaces, right? Your aerial surface and then your survey surface. And then from that, you can create a composite. And so one of the steps that Mark kind of didn't have time to go through on this session is if there's specific areas that you're interested in, you can cut out from the aerial and then paste in the area from your survey.
So if you had more detailed information in this intersection, you could cut out just this intersection, okay? And then you have a composite surface that has the intersection from the survey data. But keep in mind, know where the survey data comes from, because sometimes we send the crews out just to collect paint mark. Paint mark sometimes is collected with GPS,
Yes.
okay?
But so if we get, but just I'm not necessarily building a full surface off of the points I'm getting from them, or should I build a surface off the points I get from them?
You may want to.
Okay.
That's something Mark kind of mentioned too. Something that I did on one of my past jobs here was I created a volume surface and compared the two aerial and survey surfaces to see how accurate each surface compared to one another, and just generated a quick cut fill map. So I could see, hey, I've got 1/10 difference between the surfaces here. I've got half a foot over here. So gives you some insight on how accurate the data of the aerial is to real world conditions. So you don't necessarily want to just add those points to your aerial surface.
You'll
You
end
want to
up
cut them.
with,
You want to cut it out of your aerial and then paste just that small area into it to kind of
the other way around.
create the two.
Yes. If you got three miles of aerial and you've got 35 manholes, couldn't you just add that to your original aerial surface? Because you don't have enough data to actually build a surface on it.
True, you wouldn't. So there's a couple different approaches to that. You could add the points, but when you do that, if your survey is different from your topography, you're just going to see this huge spike out of nowhere, right? So adding those points to this
You'll
surface
get a mountain like this. that shows up.
isn't a very good solution because it's going to affect anything. The last triangle could be, let's say, 15 feet away.
Yeah.
So over that last 15 feet, you're going to get this mountain,
And
right?
one of the good ways to show that is to change the surface style to one of the styles I like to use to edit. And basically, that shows you in a more dramatic fashion how the surface is and where some of your issues might be. And this is 1/10 contours, okay? And each one of these dark ones is a foot. Okay, so when you have something that tight, you can kind of see where the information is. Okay, you can see this is a driveway. All right.
So in certain cases, Philip, like you may not need that information to be part of your surface.
Okay.
You can just use the elevation from the point itself. If you do need to add it to the surface, we would need to kind of talk a little bit about that because you can't just add a random point and expect your surface to
Behave.
feather it out.
Yeah. Because
So
the issue is, like he's saying, if I got, if they go out with the GPS and pick up paint marks on the ground, they're picking up survey manholes, they're picking up, other stuff that's out there, surface utilities, and is it worth it to add it to our existing topo?
not to add it, but to create a separate surface for it. So that all that data would go in your EX-survey surface, and then it becomes a question of which surface do you use as your profile, right?
Yeah.
You're probably going to want to use your surface, your survey surface, as long as you have enough survey data in that to stand alone. In areas that you don't, then we have to talk about creating a composite surface.
Okay.
So
So kind of like adding on to that, not just pay marks, but what about after potholing? Like we have like 500 potholes going on Power to Pomerado.
well, in those pothole information, the information where you're going to be using that the most is going to actually be where the utility is underground.
Sure. But
Okay.
You're also gonna get a surface shot.
Right. Now, one of the things you can do is compare those surface shots to your surface shot or your aerial and see how close it is.
Right. And so if it's good enough, then you don't have to do that extra work of doing like the composite or whatever. Is that kind of, I mean, alongside the paint marks. Basically, I'm saying it's like maybe between the paint marks and the potholes, you might be able to
You
get-
start getting enough survey level
points,
grade
right.
where it's very useful to your
and
project.
potholes are like the surf shot at that utility. When we know where it is, it's the most important data.
That's the point you're using to set your pipe
Right, exactly.
once you have pothole data. So that becomes part of your model to set your pipe.
Right.
So again, it's one of those things where it's engineering judgment, and each project manager is going to look at that a little differently. So you need
I know
to
on SXPQ that it's-
you need to have the conversation.
Yeah.
And something, since you brought it up, on pothole data, you should actually be projecting those points to your profile. And then you would visibly see what kind of differences you're talking about between your pothole elevation and your aerial profile, or your profile derived from your aerial surface.
Okay. I guess that makes sense.
It would also be that's a very clear way of seeing which pipe is potholed as well, because you have a point in your profile. where you have pothole
Okay, so
information.
when you have your pothole, I just can't remember off the top of my head, but you have like your elevation where you find it, but then, you know, if you're doing your pipe networks, you're still going off of a surface, right?
So when you start editing those pipes, you no longer really use the rule to set the
You
invert.
actually just use the pipes from points. And then you
Correct. So at that point, you're not setting the pipe from the surface. You're bypassing the rule. You're hard setting those invert elevations.
And if you have more than one pothole, or even if you don't have more than one pothole, you're setting that at its particular slope, if it has a slope, okay?
Right.
Because you're not just setting it flat,
Yeah.
and that, because if your alignment changes, then that projection changes as well.
Right. I mean, it's easy we do that for dips, but like if it's just like an electric or some type of telecom, we don't usually do the slope, right? I mean.
Correct. And usually you're only creating a pipe that's 10 feet long, where your finished surface isn't really changing. Cases that you need to be really careful about is where you're not going. Typically, your pipes cross the road perpendicularly, so you're only dealing with like a typical 2% crossfall. If your pipe is skewed like this and you've got some grade on your road, the amount of cover from here to here is dramatic. So your pipe should be sloped to be an accurate representation. So just kind of keep that in mind, is don't just blindly assume that it's flat and that's accurate. That's not necessarily accurate. So be careful of that, or be mindful of that.